any means technical or supposed to be real detailed or deep dive. I'm not a biologist. I'm not a professional. I'm not any kind of professional nature guy, but I am an amateur nature lover. So hopefully this just gives you some food for thought. I probably don't have all the answers, but if you want to ask questions along the way and maybe talk about something, I'm happy to pause and do that. So feel free to, raise your hand or type something in chat. I think I can see the messages, but if I miss something, Scott, please let me know. I mentioned my name's Clayton Bownds. That's my email and phone number. It's okay to text. If you have questions or whatever, feel free. I'm a Heartwood chapter member. I don't make all of the in-person chapter meetings, but that's really less about quarantine and more about distance. I live in Grimes County. I moved from Spring, Texas to Grimes County. So I think I'm the honorary Grimes County member in the chapter. So when I moved out to this neighborhood, one of the first things, I was building a house, and one of the first things that I noticed was a lot of the guidelines around, what you can and can't do, and how you can clear your land, and what sort of lawn they expect you to have, et cetera. And so first little plug I want to make is, the amount of focus that we put as a society on having these manicured turf grass lawns that are very inefficient from a drought tolerance and watering perspective, but they're not really good for the natural environment either. They don't provide a lot of food value for pollinators and native wildlife that are part of really a more complex food web and ecosystem, and everything's connected. And the more you pay attention to the stuff around you, you'll find that we're just one little piece of a much more complex system, but it's a very delicate and balanced. It wants to find balance, but we kind of interject and throw things off kilter. So lawns are usually a hot topic in homeowners associations and in planned communities, because we have this culture in America of having the manicured yard of the month. And if you do a little digging on your own, you can find that there's some native grass varietals that you can use that are more drought tolerant. And there's certainly other alternatives like xeriscaping that provide water conservation. And those things are maybe frowned upon by people that don't know the benefit that it provides. But in the state of Texas, we're actually able to do that, and the HOAs can't really keep you from planting a native, drought tolerant plant. And I put a little note here, you can read it, but the verbiage is they can't unreasonably restrict any sort of native water conservation effort that you want to do in your yard. This graphic, I think, is really powerful. If you look over on the left where the circle is, that's kind of your typical St. Augustine root structure, and all the stuff to the right, you can see that those are native plants, native grasses that actually are much more efficient at getting their moisture and nutrients from the ground, and also much better for the environment. The thing that I guess the biggest message that I try to get out to the people in my neighborhood is, our ecosystem is, it wants to find balance. If undisturbed, it really is it gets to a point of balance where everything is created in a fashion to work together. Small little creatures are either meant to be food for birds or other small little creatures. There's plants, especially if you get into the world of like butterflies and moths and lepidoptera. There's plants that are specific food plants for specific types of pollinators, and if you want to see a one type of butterfly in your yard, and that's your favorite butterfly, and you want to support that, well, you just have to find out what does the larva of that butterfly eat, and plant that, and they will come. And but the trick with having a delicately balanced ecosystem is it's very easy to throw it out of balance. And if you can envision a placid pond, glassy surface of the water, and you throw a pebble in that pond, it makes ripples, and the ripples go far and wide. And how do you stop the ripples? You can't really stop the ripples. You can't will them to stop. You can't like use some kind of mechanical force to smooth the water back out. You just have to not throw anything else in and wait. And our local ecosystems, like the yard at your house and right around you, they work the exact same way, both for flora and fauna. And so when you do something like use synthetic fertilizers, or you use insecticides or pesticides, herbicides, fungicides in a way that is there are certain, I guess, like most things, there are exceptions, but for the most part, when you use these chemicals that are not typically part of our natural environment, you're throwing the pebble in the pond. And what I observed is, people around me in my community, they're in an unjustifiable way, terrified of spiders or wasps, or they see a scorpion on the side of their house at night, and they just freak out, and then end up spraying demon around the edge of their house, or putting insecticide pellets in the yard, or andro on the ant pile, and not differentiating between invasive fire ants and native ants. And while it, the impetus of the decision to do that is they're trying to get rid of the thing that they're terrified of, the spider that they don't know is a incredibly beneficial thing to have on their patio. That pebble that they just threw in the pond has a very far-reaching effect. And a couple of examples I can give, from my own experiences. My wife and I live kind of down at the end of a street in our subdivision, in a cul-de-sac, and there's some woods around, right around our house. We barely cleared enough, for our house, and we left a lot of woods around because we wanted to encourage, wildlife. And we would find at night that people would come down, like ride their little golf cart or ATV or something, and come down and park in our cul-de-sac and hang out at night. Not like playing radio and drinking beer and partying, but they'd just be sitting there in the cul-de-sac. And this happened quite frequently. And I would go and I knew these people, several different families did this. And I eventually one day asked, and I said, "What are you doing?" And they're like, "Well, the woods around your house is the only place in the neighborhood that we can go to watch the fireflies at night." And I thought that was peculiar, because I'd see fireflies at night all the time and didn't really think that other people were missing out on them. So I started asking around, and one of my neighbors said, "Oh yeah, when we moved here, we sprayed to get rid of the spiders around the house, and we found that the butterflies went away. And we used to love watching the butterflies on our flowers, and we don't see the butterflies anymore." And we asked the exterminator about it, and he's like, "Oh well, yeah, the spider stuff kills other things too." And it just never dawned on them, but it seems like a common sense proposition. You put poison out, it's going to have a broader spectrum than the one species that you're trying to address. But the firefly topic is really interesting, because fireflies, like many insects, invertebrates, they rely on kind of the decomposition web in nature to grow from, as a shelter for eggs. A lot of animals and invertebrates lay eggs on in leaf litter, or on decaying wood, or use the ground as a incubation and growth shelter. Like fireflies could live up to 2 years. Some species, the larvae live up to 2 years underground or in the ground before that they become kind of the firefly that you see flying around and making light. And they're also heavily impacted by light pollution, which I'll talk about a little bit later. But, what was happening with the no fireflies is everybody in the neighborhood was having their lawn service come and rake up and mulch all the leaves and get rid of the leaves. And they were spraying for, spiders and scorpions around the house. And it decimated the firefly population. And we weren't doing any of that. We don't use any sort of chemicals anywhere within the property boundary of our home. And so we had a flourishing, balanced ecosystem. And so a lot of these things just existed because that was their natural state and balance. So that's, by reaching out to others in the community and kind of talking about the cause and effect of these sort of actions, I think we've reestablished a pretty healthy firefly population across the neighborhood. So that the little picture down on the bottom left is actually a species of firefly larva. And I took a picture of that because I figure a lot of people don't know what firefly larvae look like. But my wife and I were sitting out in our backyard, and I don't know if you guys have ever seen the movie Avatar, that was like an all CG movie, but on that planet that they went to at night, everything just kind of glowed and it was all bioluminescent, and it looked cool. Well, we were sitting out in the backyard one night, and all over the ground around us in the leaf litter, along the forest floor, and these little lights, like little green lights, would just light up, like the ground was sparkling and twinkling. And come to find out, that was firefly larvae, which also bioluminesce as a predatory protection, et cetera. But I took that picture of the firefly larvae on the ground, but there were, thousands of them, and it really made the ground look cool. Like, maybe not quite as dramatic as the movie, but you get the idea. Another example of the ripple in the pond that is pretty common in municipalities is dragonfly, in dragonfly population being impacted by mosquito spraying. And I have a neighbor. One of my neighbors has one of those misting systems around their house and patio, and the pitch from the people that, I guess, I don't know who sells them, pest control people or whatever, but the pitch was, oh, it's natural, all natural, and it's not harmful to people and pets and yada yada yada. Well, the municipal mosquito spraying, like the mosquito truck that goes and sprays, we all know that it's bad for things like other pollinators like bees and that sort of thing. But what happens is, when you kill the mosquitoes with the mosquito sprayer poison, you're also killing dragonflies and dragonfly larvae. Dragonflies are one of the largest biological integrated pest management systems that we have for mosquitoes, because not only do the nymphs live in water before they transition to the flight form as an adult that we're all familiar with, but mosquito larvae live in water. And so dragonflies not only are voracious predators of mosquito larvae when they're nymphs, but also they eat a lot of mosquitoes as adults. And the problem is when you spray for mosquitoes, whether it's you spraying or your city spraying, it kills the mosquitoes, kills the dragonflies, but the mosquito population bounces back much, much faster, like many times faster. Takes a long time for the dragonfly population to bounce back. So it's really weird to think about, but spraying for mosquitoes actually increases the number of mosquitoes. It you get an immediate benefit of what you just killed, but the long-term effect is more mosquitoes, because you're removing one of the largest biological mosquito murderers out there, which is the dragonfly. I put the little dragonflies are the mosquitoes what John Wick is to bad guys. That's true. So like the other slides, and I will say there's 2 or 3 photos in the whole presentation that I didn't take, but every picture you see in here for the most part are pictures of mine. And more often than not, they're pictures that I took here at my house in the backyard. So the little nymph picture in the upper left, that is maybe not the exact dragonfly, but the slaty skimmer in the bottom right on the alligator flag right here. That is the species that came from this nymph. So have quite a few dragonfly species here, and I'll talk about kind of observation of nature and species diversification later on in this little talk. But this is just a good example of the pebble in the pond analogy, where you are trying to be very prescriptive about controlling one species, but it's a far-reaching effect on other species and throwing the ecosystem balance out of whack. Let's see here. So pollinators. Let's talk about pollinators. Pollinators are incredibly important to many things, right? Not just balance of the ecosystem, because so many different plants and angiosperms, flowering plants, rely on pollinators for reproduction, but also, we rely on pollinators for agriculture, for most of the food that we eat, most of the natural food, not necessarily some of the crazy stuff that's in the supermarket today, but most of the things that are grown for consumption rely on pollinators to exist. And I think when most people think of pollinators, they think of bees, and but really pollinators it's a much broader spectrum of species. Lepidoptera, butterflies, moths, beetles, wasps, birds, they're all pollinators. Bats are very, very important pollinators, and there are several species of plants in Texas that rely on bats to be pollinated. And so, lots of people want to see the pretty birds and the pretty butterflies, and so they want more of that in their yard, for the selfish reason of viewing them and appreciating them, but and not so much on the important role that they play in the ecosystem. And they're like, well, how do I get more pollinators in my yard? And the truth of the matter is, you just need to focus on planting native plants and supporting native plants, minimizing invasives and non-natives, but supporting native plants, and the pollinators will come in mass. And if you want to keep pollinators around, then you need to get rid of the chemical use and the things, especially broad spectrum pesticides, but the pesticides, insecticides, and herbicides that are overused in our yards today are devastating to not just local ecosystem balance, but the survival of many species that are so vital. Pollinators are definitely one. Fun pollinator facts. This is kind of neat. So when you say pollinator to the average Joe, most people think of bees, right? Oh, we need save the bees. Bees are the pollinators that we have to focus on. And when you say bee to most people, they think of a honeybee, Winnie the Pooh and all of that. Honeybees being shipped to California for the almond crops on trucks, and honeybees making honey that you buy at the county fair. And but the truth of the matter is, bees are important pollinators, but honeybees are not even native to the United States. Honeybees are livestock that were brought over from Europe. There's a couple of different subspecies of honeybees in Africa and Asia, but for the most part, the genetics of the honeybee are European, and we have continued to grow the honeybee population for livestock, honey production and pollination, agricultural, mass, factory farmed pollination. But there are over 4,000 species of native bees, the honeybee not being one of them, but native bees. All these pictures on this slide are native bees from my yard. Bumblebees and sweat bees and mason bees and sunflower bees, all different shapes and sizes. I have if you look kind of on the left, there's some native frog fruit, which is one of my favorite ground covers of all time. And the ruler there shows how big the flower of the frog fruit is, turkey tangled frog fruit, and there's a native bee on it. So that would be one of the smaller species around. And then they get up to, bumblebee size, and they're quite beautiful, very, very diverse in appearance and colors and how they carry pollen, and just fascinating to observe and to learn about. About 1,100 of the native bee species in the United States actually are native to Texas. So you got a lot of bee watching to do if you're into bees, without looking at honeybees. And I used to keep honeybees when I moved out here, kind of part of my how do I better support nature? I'm going to save the bees. And I didn't really keep honeybees for the honey, while that was kind of a nice, side benefit. I really just wanted to help the bees. And there was a lot of press in the United States about colony collapse disorder, and speculation around why that was going on, and what you can do, and big noteworthy quotes like one person keeping one commercial beekeeper with 60,000 beehives isn't going to change the world, but 60,000 people with one beehive in their yard is going to change the world. And I bought into all that. And don't get me wrong, certainly I would encourage anyone that wants to keep honeybees, do it. It's a very great educational experience, and I really had a great connection to that learning path. But what I did as I started observing diversity in my yard and activity, you really start to pay attention. What I noticed was I'd go outside and I plant native wildflowers in the fall, September, October, November timeframe, and in the spring when those flowers bloomed, I would see thousands of honeybees everywhere. My yard would just sound like you had a white noise machine, just buzz, like the buzz of honeybees everywhere. But I didn't really see as many native bees. And I thought, for a fixed amount of food, right? Bees use nectar as a carbohydrate and pollen as a protein, and that's their food source from flowers. For a fixed amount of food, these honeybees are just like, they're being pigs. They're eating it all. And I really just felt on my heart this whole non-native versus native thing. And so I got rid of after I kept bees for about 5 years. I typically had about 4 colonies per season that would overwinter, and I lost some here and there through absconding and various things. But for the most part, when I got rid of my honeybees, my native bee population rebounded, and I really saw a lot more, not just quantity but diversity of native bees in my yard. And so the other little thing I want to say here is, most native bees are solitary. That they don't have big gregarious or social, colony type structures. There are some that do have small colonies, like bumblebees have colonies, et cetera. But most of the native bees you see around are solitary. And about over 70% of native bees actually live in the ground. And I wanted to say that because it kind of underscores the importance of being cautious with lawn chemicals, because what you put on your lawn directly impacts, native pollinators that are living under your lawn. So just food for thought there. So I mentioned that, a lot of aversion to creepy crawlies. So I wanted to address some common questions or concerns. Spiders and scorpions that you might see around. Unless you're specifically allergic to the venom of a spider or a bee or whatever, typically they're harmless. And there's only really 2 species of spider that are native to Texas that have any sort of medical significance to people. In other words, they could potentially make you sick or harm you in some way other than just, itchy irritation. And that's the black widow and the brown recluse. And they're both native to Texas. There's only 1 species of scorpion in the entire United States that is medically significant to humans, and it doesn't live in Texas. It's farther west, Arizona bark scorpion. But the interesting thing is when there's such a stigma around these black widow spider and brown recluse and the scorpion, and people really get freaked out, and I don't want those around my pets, and I don't want those around my kids playing on the patio. And I just can't. That's where I draw the line. I love nature, but that's where I draw the line. I have to kill these creatures because it's just, the risk is too great. I'll talk about snakes in a minute, but much like snakes, species that have venom, and that's how they hunt for food and capture their prey. Venom is very, very tasking and resource intensive for them to manufacture, and it's a very, very precious commodity. And unless you are considered a prey species, they don't want to give you any of their precious venom. And so typically what you see when people get bit by spiders or stung by scorpions or bitten by snakes, it's because those creatures are trying to defend themselves from mortal danger. So I'm here to tell you, you can live alongside these species if you can kind of wrangle in your fear and learn a bit more about their beneficial place in our ecosystem. I have black widow spiders in my garage. They don't charge a lot of money for pest control. They're fantastic and efficient at that. Scorpions, my wife has this irrational fear of cockroaches, and scorpions prey on cockroaches. So they're appreciated here from her standpoint. But I guess the takeaway is there's not as many perceptibly dangerous things out there in the natural environment. And if you learn a little bit about them and kind of their behavior in biology and how they fit into the greater complex web of the local ecosystem, you can appreciate that everything has a place. And if you look at it from an evolutionary standpoint, the things that have survived and evolved through millions of years, many of which have become specialized, there's a reason that they're still around, and that reason is important. We just kind of have to task ourselves with, figuring out what that is, right? Learning a little bit more about it. And then I think at some point in time, as you learn more, you kind of have a light bulb moment, this epiphany, like, oh, we're just one little piece of a much larger puzzle, and every piece of the puzzle is very important. Fun fact about scorpions: there's some chemicals. There's a couple of compounds in the cuticle, actually the hyaline layer of the exoskeleton of scorpions and other arachnids, but more so, like it's very evident in scorpions, that fluoresces in ultraviolet light. So I put a little picture of that flashlight. I ordered one of those off of Amazon. You can find them at sporting goods stores or whatever, but I think it was like 12 bucks on Amazon. A little UV or blacklight flashlight. And assuming you haven't decimated your scorpion population with insecticide use at your home, you can probably go out with one of those blacklight flashlights and find scorpions in the woods around your house, because they glow, like the picture there on the left of the glowy scorpion that was on my driveway, and they really stand out. It's super fun. It's a fun thing to do with kids, and gives you an opportunity to talk about the species and talk about the importance. Spiders, the other creepy crawly that everybody hates. Spiders are awesome. They're great pest control. Typically pretty good to have around, not just for the pest control, but also because they are so diverse and just really interesting to look at. All these spiders here are spiders from around my yard. See the little guy, the little green link spider eating the fly, and the spiders sucking the juice out of the ant there, and they're just really cool. The wolf spider on the left, see all the babies on the back. That's something that's I don't know if it's unique in the world, but it's kind of unique around here, in that species carries its young on its back until they're first molt, and then they kind of go off on their own. Spiders come in all shapes and sizes, and you know, they all, just like scorpions, they have a very important role in keeping our ecosystem in balance. So just think about that, and before you come spraying the exterminate, let the exterminator spray at your house. Snakes are a pretty sensitive topic. I'll cover, there's a couple of slides here on snakes because I want people to, one, have at least a very rudimentary way of identifying what snakes are looking at, but there are no bad snakes. The whole, you know, the only good snake is a dead snake. That's a horrible cliche. Snakes are an important part of our ecosystem. They help keep rodent population in check. You know, they just like with the invertebrates that are venomous, you know, venom is precious to them. They don't look at you as prey. They don't, well, I'll talk about some snake myths in a future slide, but you know, they don't chase you. They don't want to get you. They actually just want to be left alone. And you know, most natural species, non-human natural species, care about you know, food, water, and shelter, and you know, and their safety. So I think that if you can just learn the basic 4 types of venomous snake that we have in Texas, there's only 4. 3 of them are pit vipers, and then 1 of them is an elapid. That's the coral snake. It's related to the cobra. But these are pictures of the 4 types of venomous snakes that we have in Texas. The left, we have the copperhead. The copperhead up further north of us. I would say maybe there's some outliers that get close to, you know, maybe the Madisonville, Huntsville area. I could be wrong on that, but that's the broad-banded copperhead up in the left. You see how the bands are wide and kind of go all the way around the snake. But the 2 copperhead photos below that on the left, I don't know if you can see my mouse in the screen or not, but these with the little Hershey kiss pattern along, this is, you can see it really well here. It kind of looks like a Hershey's kiss. That's the eastern or southern copperhead. That's the type of copperhead that we have around here. A lot of venomous snake bites come from this snake, and it's not because the snake is typically, you know, more dangerous or anything like that. It's because the defensive mechanism of the copperhead is to just hold super still as it can possibly be, and try and be camouflaged in the you know, the ground around the snake. So these, a lot of times you'll see these in leaf litter, and they're much more blended. Those pictures were pictures from my yard, and there was some green grass around, so there's contrast and you can see the snake. But typically, if you come up on a copperhead, or your dog comes up on the copperhead or whatever, the snake is just going to try and play dead. I mean, not play dead, but you know, be perfectly still. And so that, because there's no, they're such good at camouflage, and there's no real audible or visual motion to warn you or catch your eye, catch your periph, they're pretty easy to step on. So just be wary of where you step. But the snakes, you know, by and large, for the number of bites that happen because people step on these snakes or try and pick them up, they're not as deadly as people think. The cottonmouth is another pit viper that's native to Texas. It's very close, from a very close cousin to the copperhead. I think there's even been some records of hybridization between the 2 species, but cottonmouth has a really bad reputation. Lots of people say, oh, you know, they'll chase you, they're aggressive. I do want to say that there are no species of aggressive snakes anywhere in the United States of America. Snakes just want to be left alone, and their first line of defense is to flee, with the exception of the copperhead, which will hold still until it thinks it has a window to flee, and then it will flee. And then the rattlesnake, most of the time they're pretty easy to identify because they have rattles. There are some rattlesnakes that you might see that don't have rattles because they were either you know, damaged somehow, or there's a mutation where they didn't develop rattles, but you can typically find, you know, rattles is the good, how am I defining aggressive in this capacity? So if you can imagine being a snake and having a person or a dog or something, you know, approach you, you don't, there's not this capacity of, oh, that's, you know, that's a person that just wants to look at me, or that's a dog that just wants to sniff me. You look like a predator that wants to harm, you know, kill or eat me, right? So snakes are very defensive, and so, and it's just a protection of, you know, to protect their own safety, their own life. And so snakes that, you know, much like, I'll give you a good parallel example, Africanized honeybees. People say Africanized honeybees are aggressive. They're actually not, they're just very defensive. And there's a function in a bee hive, a bee colony, called a guard bee. And guard bees, their job is to keep stuff away from the queen in the hive, the resources in the hive. Africanized genetics in honeybees, those guard bees, they're the range at which they perceive a threat, and how quickly they want to get the threat away, is more pronounced, and so they're more defensive. And so snakes, when I say there are no aggressive snakes, I'm saying that if there is a snake that doesn't perceive you in any way as a threat, then that snake will just ignore you. There's snakes will not go after you. But if you approach the snake in such a way that it perceives you as a threat, the snake will defend itself. So snakes are defensive, not aggressive. I think that that's just a perception. You know, people perceive defensive behavior as being aggressive, but really they're just terrified that you're going to kill them. And then the coral snake on the right is very colorful. It's very, very common. Yeah, observing a coral snake is not common. They're very, very shy. They're very quick to run away if they think that you're around. You know, it's hard to see them because they're good at being elusive. That photograph is not actually in my yard because I have observed coral snakes in my yard and taken pictures, but I couldn't get the whole snake in the picture because it was under a bunch of leaves and running away. So I wanted you to see the snake. But the thing that I wanted to say about coral snakes is, well, before I say that, I'll say the three pit vipers, the venom is hemotoxic. That means it affects the blood and coagulation of the blood and does tissue damage. Whereas the coral snake venom, it's a remote, they actually loosely call them North American cobras because they're related to the cobra, but it's a neurotoxic venom, so it affects the central nervous system, and so that's the difference between, you know, venom impact in those snakes. And the thing about the coral snake that's kind of important is, you know, you hear the rhyme about, you know, red on yellow kill a fellow, red on black friended Jack. My grandfather told me that when I was a little kid, and everybody uses that. That's not true all the time. It's true in the case of the coral snakes that we have here, the Texas coral snakes, that are not aberrant in any way. And so much like, you know, we have people that are born with birthmarks or, you know, different skin pigmentation, or, you know, freckles or alopecia with no hair. Like we're all still people and we're all the same, but we can look different because of a genetic, you know, abnormality. Snakes are the same way. They can be born or hatched. I guess I could say that too. These pit viper snakes here that I'm talking about, they give live birth. They don't lay eggs, so that they give birth to little living baby snakes. Whereas a lot of snakes that we have in Texas will lay eggs, and the eggs hatch, and that's how you get baby snakes. So, but snakes can be born with abnormalities or aberrant, you know, skin coloration or patterns, and that throws off the cliche or thumb rule, you know, rhyme. So don't use that as the only thing if you're trying to identify, say, a coral snake, because It's not 100% true all the time. Let's see. You can't make antivenom without venom. That's true. Snake venom is really critical, not just for the production of antivenom to treat people who get bit by a snake, but there's, snake venom is a very, very big positive contributor to medical science. And there's a lot of research done around cardiovascular health, treatment of high blood pressure, breast cancer research, recovery from stroke, medications for stroke recovery. A lot of those medications and advancements in medical science are directly tied to snake venom. And if you kill the snakes, we can't get the venom. Anyway, very many benefits in the ecosystem. So just keep that in mind. Snakes aren't out to try and get you. They're just trying to be safe and find food, water, and shelter. Let's see. Here we go. Common snake myths. We'll just go through these real quick. So coral snakes have rear fangs. Absolutely not true. Coral snakes have fixed front fangs. So unlike pit vipers that have retractable fangs, coral snake fangs are fixed. They're smaller, they're shorter, but they are definitely not rear fangs. They're in the front. They don't have to chew to envenomate. They can strike and envenomate just like any other snake. We already talked about this coral snake rhyme and how it's not 100% always true because you could have aberrant. I don't know if I have pictures in here, but just be careful about that. You can tell it's venomous because it has slit pupils, or you can tell it's safe because it has round pupils. That is not true. Snake pupils work kind of like our pupils, except for when they're constricted, they're not perfectly round, but basically they dilate with light, just like our pupils do. So in low light or dark, snake pupils can be round, and so don't use that as the only thing to say, oh, that's a safe snake, or, not safe snake. Rattlesnakes always rattle, or non-venomous snakes don't rattle. That's not true. Rattlesnakes often will not rattle, and non-venomous snakes will very often rattle their tails because it's a mimicry behavior. It's like, okay, in the wild, this predator knows that if, the rattlesnake is rattling its tail, that's, leave it alone, danger, Will Robinson. So I'm gonna rattle my tail to trick it, thinking I'm a big bad rattlesnake. So that happens a lot. A lot of non-venomous species of snakes you'll see will rattle their tail in mimicry. Snakes will chase you, especially water moccasins. Absolutely not true. Copperheads smell like cucumbers. I don't know where this rumor came from, but that is also not true. Venomous snakes always swim on top of the water. Not true. Snakes control their buoyancy just like we do with air in their lungs. Venomous snakes can go underwater, and non-venomous snakes can swim on top of the water. Not true. I don't know where that came from. Baby venomous snakes can't control their venom delivery and always dump it all on a bite. That is not true. Baby snakes are born, baby pit vipers born with the 100% control of the venom load delivered and control of the venom gland, just like they are as adults. Adult snakes are actually typically potentially more dangerous because they can produce more venom and the venom load is proportionately larger. But baby snakes not being able to control their venom and giving it all to you on a bite is not true. Mothballs, sulfur, snake away products work to keep snakes away. Absolutely not true. And not only that, I believe that environmentally it is illegal to use mothballs for something other than what they're intended. So don't do that. It's bad for the environment. You can tell a snake is venomous by the shape of its head, like if it's triangular, it's venomous. That is not true because much like the tail rattle mimicry, snakes, non-venomous snakes can flatten their body out to make them look wider and bigger and make their head look bigger and it kind of looks triangular. That is a mimicry also of say a viper, and it's just a defensive display, right? Okay. Oh, here I do have some pictures. All right. I didn't take all of these. These are from the interwebs. Here's some pictures of coral snakes' front fangs, just visualizing the myth buster there. The red and yellow rhyme, these snakes on the bottom are all coral snakes. You can tell that they don't exactly follow the rhyme exactly. The myth about the pupils, so these are copperheads. which are native and around here. Low light environment, you get pupil dilation, and certainly if you saw that snake and were only use the eyeball thumb rule, that would not work out well. You should never, I say this, it's kind of common sense, but you should never pick up a snake. You really should never pick up a snake, but you should definitely never pick up a snake or mess with being around a snake unless you absolutely know what it is. Most snake bites, I don't know the exact statistic, but it's north of 90%. I've heard 95% of snake bites really come from people either trying to pick up the snake or to kill the snake. In order to kill the snake with whatever, your garden hoe or, lawn shears or whatever it is you're going to do to try and kill the snake, it puts you in close proximity. It makes the snake feel like it needs to defend itself, and certainly you could be within striking distance and get bit. So just let snakes go about their business. They'll leave you alone, and all will be good. Here's the myth about venomous snakes always being on top of the water. That is a cottonmouth down underneath at the bottom of the water, chilling out. Mothballs and snake away products worth. There's a juvenile viper wrapped around a mothball there. Absolutely false. They don't really care about that. But they are bad for the environment, so don't use mothballs outside. The myth buster about the head shape. So that is a Western rat snake on the left there with this big menacing triangular head. They're absolutely non-venomous. They're a constrictor species. They're great for the environment. They keep a lot of rodent population in check, and just cool snakes to have around. The defensive posture that I talked about flattening out the head. So if you look at the bottom left, that's the same snake in a defensive posture versus not in a defensive posture. You can see the head shape drastically changes as they flatten their body out, flatten their head out. And then all these pictures on the right, these are different species of native non-venomous snakes, like garter snakes, plain-bellied water snake, broad-banded water snake, rat snake, and they're squashed out trying to mimic a venomous viper and look like they're a venomous snake to protect themselves. It's just behavioral, and you can't use those clues as identifiers for venomous or non-venomous. Let's see. So these are just some pictures so you kind of get an idea of some of the different non-venomous snakes that we have around here. Water snakes are pretty common, and rat snakes are pretty common in the Houston area. You see those quite frequently. Maybe more infrequently, but also a common species would be the eastern hognose. These snakes right here are all different pigment and coloration versions of the same species of snake. This black one is kind of a melanistic phase. This right here, I think I took this picture in my yard. I love these snakes. These are great snakes. They are venomous. People say, oh, the hognose is non-venomous. They are venomous. They have a very mild venom that is evolutionarily developed for frogs and toads. They specifically have this purpose-built venom for frogs and toads. That's what they love to eat. They have rear fangs, and they use the fangs to puncture the toad, because typically they bite the toad and it puffs up with the air to try and prevent the snake from being able to swallow it. They use the fangs to puncture the toad, and the venom incapacitates it so it doesn't wiggle around as much while they're trying to swallow it. But typically, if I rarely have ever heard of anyone being envenomated by a hognose, but it's I've heard it's kind of like a wasp sting or something like that. But if you don't pick them up, you don't have to worry about that. But they are really beautiful snakes. One thing about the hognose snake that's kind of cool is they play dead. If they get stressed enough to where they feel like they need to, they'll actually just flop over and pretend like they're dead. And it's a very dramatic display. And so kind of the drama queen of the eastern non-venomous snake world. And over on the right, the pinky and the brown snakes in the middle, those are coach whips. They come in a lot of different shades. I haven't ever seen any pink ones around here, but you know, further out West Texas, you see those quite a bit. Over 70 different native species of snakes in Texas, and they're good to have around. Some other identification help here. Eye placement is one thing that you can use. A lot of non-venomous species, you will be able to see the eyes from the top of the snake, whereas the viper species, the eyes are more on the side and they're not as visible from the top. Non-venomous species of water snakes have these vertical bars on the edge of the jaw and the lip, whereas venomous species do not. These plain belly water snake pictures here, these were in my backyard. It's probably the most commonly seen species in my yard is plain bellied water snakes. So, a couple other quick ID things for snakes. I wouldn't suggest using this as an identifier in the field, but if you come across a dead snake or roadkill or something and you're curious, there's right kind of in the rear portion of the snake underneath, there's a vent where they poop, and if the scale pattern changes from a single row of scales to a double row of scales at the anal vent, that is a non-venomous species, whereas venomous species, they do not change to a double row. And then just some, you know, people see diamondback water snakes. A lot of times they think that they're cottonmouths. These are just kind of a visual reference, so you kind of get an idea there. Pit vipers are called pit vipers because they have these little pits on the side of their nose area. That's how it's kind of a thermal sensor. That's how they can smell. I mean, they smell with their tongue, but they can sense heat with these pits, and that's how they track down prey and get a better sense of the world around them. Pit viper, not rattlesnakes, but the pit vipers in Texas, the water moccasins and copperheads, they're born with caudal lures. Their tails are kind of a bright yellow or greenish yellow. Like I said, pit vipers are born live, so these baby juvenile snakes come out with these caudal lures. They don't know how to hunt yet. They don't know how to seek prey. So the way that they can eat is they just sit and they kind of wiggle that tail and prey animals, birds, specifically birds. They're like, oh, that looks like a beautiful juicy worm that would be delicious, and they come down to eat it, and the snake can bite the bird, and that's how they can eat until they get old enough to learn how to hunt. When they get a little bit older and learn how to hunt, they get out of that juvenile stage. They lose that caudal lure color, and the coloration of their body and pattern, it will extend all the way through the end of the tail. So if you see a copperhead or a water moccasin, a copperhead or a cottonmouth, which typically people call cottonmouths, water moccasins. If you see them and they don't have the caudal lure color, then that's not a juvenile snake. That's an adult snake. And then if you see a snake, you don't know what it is, but it has this bright green yellow tail tip. Chances are it's a baby pit viper in one of those two species. Some more pictures of native non-venomous species around our area, with the exception of the indigo is not really around here. That's kind of further west and south, but the buttermilk racer, it's kind of a subspecies of the black racer. Garter snakes, ribbon snakes, rat snakes, all very common. This one right here, Decay's brown snake, this is pretty common to see like in your flower bed, maybe off your patio. These snakes kind of specialize in eating slugs and snails. And if you have a little landscape area around your house that you see slugs and snails, you might see Decay's brown snakes looking for a snack. And then snakes many snakes don't just eat, squirrels and birds, but they'll eat other snakes. Some species are specialized, like the king snake and the indigo and the coral snake. They're pretty good at taking care of other snake species, and a lot of times the prey of these snakes, especially the indigo and the king snake, will be venomous snakes. So non-venomous snakes help keep venomous snake population in check, and so it goes back to that whole ecosystem balance and everything having a place in a design in a larger complex web. All right, so got through the snake slides. Other wildlife that you might see around, bunnies and squirrels and deer and coyote and raccoons, and these are all very common things to see. We have at our house here, we have gray fox, we have bobcat, we have bats. I'm kind of on my punch list is to put up some bat houses. I haven't done that yet, but we have bats around here. I think that the more balanced your local ecosystem is, then the more welcoming it will be for a greater diversity of species. And at the very end of the presentation, which I'm actually almost to the end, but at the very end, I'll talk about, kind of what I've done observing the species around my house and what you can do too. And that helps you to not only be more aware and not take for granted what is around you, the natural world around you, but it helps you to learn and kind of develop a sense for, cause and effect in the things that you do, application of chemicals or not, what you plant, what you nurture, behavior around light pollution, et cetera. You'll be able to actually observe a natural ecosystem response to your actions. And so a couple other fun stuff about some other animals around. We have a lot of armadillos in our immediate area where I live. Most people in my neighborhood absolutely hate them because they dig up little holes in the flower bed or little holes in the yard. They're looking for grubs. It's free grub control. I don't have to spray a chemical on my yard to get rid of the grubs, because at night while I'm sleeping, my little armadillo crew comes and eats the grubs. The 9-banded armadillo is actually the only armadillo species in the United States. They don't always have exactly 9 bands. It can be, 7 to 11 bands. They always have quadruplets, always, and they're always the same sex. So they're always going to have 4 identical quadruplet boys or identical quadruplet girls. It's really fascinating. I don't know why that is. Doesn't vary. It's kind of a cool fun fact about armadillos. It's the armadillos are the state small mammal. So possums, possums are fascinating creatures. They're almost completely resistant to rabies. So if somebody says, oh, rabid possums, it's highly unlikely. They are beneficial in many ways. One of the ways is they eat a lot of ticks. It's the only marsupial that we have native to the United States. And they're also immune to almost all snake venom. So possums eat snakes. Maybe not their primary food source, but if given the opportunity, they will eat a snake. But they're not impacted by snake venom at all. We have a lot of invasive species in Texas. A lot of that is anthropogenic, like propagation. We bring plants in that are pretty that don't live here, and those plants, are I guess highly successful in our climate or our local, our local temperate environment, and they end up, kind of spreading and taking over and displacing native plants, and that displaces food and upsets the balance of the ecosystem, just like us, bringing in a synthetic or a chemical interaction. A non-native species of plant can unbalance the ecosystem locally, just like that. A good example of that around Houston, and really all the eastern piney woods area is Chinese tallow trees. Absolutely horrible, terrible invasive species that needs to be eradicated. But not just plants, we have invasive species of animals as well. Feral hogs, feral pigs are a big problem in Texas, not just with damage, economic impact to the damage that they have with the agricultural industry, but they'll tear your yard up pretty bad too if they can get to it and they're looking for something underground to eat. They propagate very quickly, and it's a challenge in Texas to keep the population in check. We're actually losing the battle. So there's a website called texasinvasives.org. You can go check it out. There's a lot of good information on all the different listed invasive species that Texas Parks and Wildlife is tracking. There's a way that you can report. It's worthwhile to check that out. I think they have an app, but you can go check out the website. And I'm not 100% sure, but if you kind of pay attention year in and year out, usually there's at least one Texas invasives workshop or training with Texas Master Naturalists annually. So plug into that if you've never been to one. It's worthwhile, and it helps you kind of keep an eye out for protecting the environment. More feral hogs in Texas than all the US combined. I would believe that, yeah. All right, light pollution. This is kind of, it's off a lot of people's radar. It's near and dear to my heart. I think that, the city, especially large planned communities, this light pollution is kind of an afterthought, and people don't think about the impact of it. The lighting at night is I guess, socially tied to like security. It's like, oh, we need a security light. We need to be able to see. It's safer. But the truth is all living creatures have this circadian rhythm that, over millions of years, basically life kind of was active or inactive based on the cycle of sunlight. And, light pollution actually impacts both, nocturnal species, which that would make sense, lights on at night, but diurnal species are impacted as well. It's not good for your health to have this abnormal, lights on after dark because it impacts your circadian rhythm. But, what it really does is it impacts wildlife and, migratory patterns. And, you can go do your own research on it and read about it, but, baby sea turtles get into the ocean safely, being impacted because lights on piers or, along the beach, or, the impact of light pollution on things like firefly. Firefly population is adversely impacted because of artificial lights that we have at night, because the communication of that invertebrate is via light and light signaling. You ever go and see like a mercury vapor bulb on the side of a gas station, and there's just a gazillion beetles and light, moths and everything around the light? That's not normal. That's not normal behavior. And then the other thing, and maybe this is a little bit more selfish for me because I like to look at the stars, is, it's very hard to see the stars in the sky with artificial light, giving you this kind of light dome or light glow in urban areas especially. But it travels a lot farther than you think. An unshielded light on your patio or porch or driveway it has a lot larger impact to the overall light pollution problem than you might realize. There are a lot of, the IDA has a lot of guidance you can go download to help you plan a better light pollution strategy around your residence, around, what types of light, what types of lights as far as temperature and bulb type are more light pollution friendly or not. Shielding the light, making sure it's pointed down and there's not a lot of spill. All these things you can read about and make smarter choices. Have your lights outside, like, if you want to have a light in your driveway or on your porch at night, put it on a motion sensor so that it's off all the time until something, gets in the way, and then turns it on, or put it on a photocell so that, motion sensor and photocell so that it doesn't come on except for, during certain times, and it's when it's nighttime outside. All these things are little things that add up to solve a much larger problem. You might feel like your actions around, light choices with light pollution, and choices with chemical use, and choices with planting native or non-native are inconsequential in the big picture. But the truth is, you can't really change the world until you kind of change yourself and start at home. And if everybody did that, then the cumulative change would be impactful on a large scale. And I feel like we're kind of stealing the night sky from our children and future generations. We live a little bit outside of Houston, so on a clear night at night, we can see quite a few stars, and it feels special. But my birthday, my wife and I, we have a birthday in August, 3 days apart. This year we went to, or 2020, we went to Jackson Hole for our birthday and hiked Teton, Grand Teton National Park. And one night we went out on a clear night to Antelope Flats outside of Jackson Hole. And let me tell you, looking up at the stars there is breathtaking. I mean, you can't even describe the brilliance of, billions of stars illuminating the surface of the earth by just pure starlight. It's crazy. And I read this, it's been, 10 years ago, but I read this essay that was written by a girl that went on vacation with her family to like the Grand Canyon or somewhere when she was 23 years old. And she was born and raised in New York City and grew up in New York City. And the essay was about how impactful and kind of on a spiritual level, seeing the night sky in a dark sky area. That was the first time she'd ever seen the Milky Way at 23 years old, never seen it because she lived in the city and couldn't see it. So just something to think about. You can make some small changes at home that will help, not just, at your house, but help your neighbors and help the community around you. And then I wanted to throw this slide in. Light pollution prevents us from being able to see the stars. I took all these pictures, from my yard. So it's hard to appreciate the beauty of the universe if we're blinding it out with light pollution. So that's it for the nature part. I just have a couple of quick slides about iNaturalist, because one of the things that I did when I came out to this new home in a more rural neighborhood is I wanted to, in parallel to this effort of, hey, do no harm, don't upset the ecosystem with, synthetic fertilizers and all the sides, the pesticides and herbicides and fungicides and plant native and all these things that I wanted to do to contribute to make sure that at least within the boundaries of my little lot around my house, that I was going to have a localized instance of a ecosystem imbalance and support, flourishing native wildlife, et cetera. I wanted to be able to track how I was doing and kind of keep an idea of changes over time. And so there is a joint project with it's the California Academy of Sciences and National Geographic came together, and they created this platform called iNaturalist. I'm sure many of you have already heard of it, but the gist of it is it's a citizen science database that allows anyone in the world that has a camera or a phone with a camera to observe the natural world around them. And that's, it's not just animals, it's not just birds or bugs or trees or grasses or flowers. It's basically all living things in the tree of life. And you can photograph or make an audio recording. There's a couple of different ways that you can make an observation, but you basically are observing a living thing and tagging that with metadata around where you observed it, lat long, the location on Earth that you observed it, and when you observed it, and that goes into this database. you know, I'm not a scientist, and, you know, maybe there are some scientists in the audience, you know, wildlife biologists or botanists or whatever, but I'm not one of those. But my observations are available to real science. And so if you think about it, you know, what's the big deal? If you look at the stats, I pulled those stats last night off of iNaturalist. So as of last night, before I went to bed, there were 56 million observations in iNaturalist, representing 313,645 species and almost 1.5 million observers all around the world. Well, if you're a scientist doing research on a particular genera, it's a lot easier to have data from, you know, lots of observers all over the world that you can you know, validate the accuracy of and choose to use or not use in real science. And it's all kind of volunteer. In a little bit of a selfish way, I didn't really enter into my use of iNaturalist because of some great contribution to science that I wanted to do, but it was really to catalog the biodiversity that I observed in my backyard, and not just catalog it, you know, holistically, but be able to tell over time and season over season, you know, what species came through at what times and how they interacted, and iNaturalist is a great tool to do that. So when you create a free account with iNaturalist, you can do it. It's probably easier if you do it on your computer at inaturalist.org, but you know, there's an app you can use as well. It kind of works a little bit like if you're familiar with social media platforms like Facebook or Instagram or these types of things, where you have a profile, you have an account that's kind of your space there, but it's not a social platform in really the sense that you interact with other people in a social way, as much as you can interact with their observations. You can identify other people's observations. If you say, I take a picture of a flower and I have no idea what it is, but Mari knows what it is, and she can go on my observation and say, oh, well, you know, I know exactly what that is, and post a suggestion of what that flower might be. Well, it's public for everyone on iNaturalist to be able to chime in or not, to validate the accuracy of that ID. And so what happens is this kind of this community classification where, you know, I take a picture of a bird. Well, I don't really know what it is, but it's got wings and feathers and a beak and it flies, so it's a bird. And then somebody else says, well, you know, I don't know exactly what kind of bird it is, but it's, you know, from this family or this genus. And eventually, through community effort and checks and balances, you can get down to the species level many times and validate that observation as a grade of quality that will help a scientist somewhere where that data is meaningful, do real research. And in essence, that is what citizen science is. This is just a great tool to be a central repository for the citizen science that happens around the world. In my case, it's biodiversity. It's a biodiversity project in my backyard, you know, kind of like a backyard list, but that's available for science to use. And you can have, like, you know, favorite taxa that you want to track and keep lists that are meaningful to you. You can write journal posts and so there is a little bit of a human element to it. I put tardigrades as one of my favorite taxa because I wanted to find one for a long time and I wasn't able to for many years. But now, a fun fact about me, I have more tardigrade observations than anyone on planet Earth on iNaturalist. So kind of a geeky thing about me. You can go back over time and you can see everywhere that you've made observations. You know, you can look at them on a map. You can query, you know, by species or anywhere in the taxonomic tree. You can drill down and pull stats and track things over time. This is just the kind of the global map of my observations. There are people out there that have done way more observations than me. I've got about 4,500 observations. Most of those are in my yard, but I have observed, you know, from the road. This is my project for my backyard. I've observed 971, well, observed about 3,300 observations in my backyard, but I identified or classified 971 different species in my backyard, and that's plants, animals, and invertebrates, et cetera. And it's really just become a passion for me, because I feel like the time that you spend observing and becoming a good noticer and watching the natural world around you and how things interact, not only does it foster curiosity and help you to be inspired to go learn about those things, which helps you become a better steward of the land, better steward of the natural ecosystem around you, but it's really kind of a therapeutic in a way. It connects you to something greater, and reminds you that we're on this rock in space together, and everything, every action and everything we do matters to a larger interconnected web than just our typical day-to-day of staring at our cell phone or watching TV. So I encourage you to try it and get out and learn about the world around you, and try and be a better steward of that environment. And then every year, I'll tell you this, it's kind of super fun too. Every year there's an algorithm you can plug into at the end of the year. They usually open it up around December timeframe, and it'll go out and it'll run all the stats for your previous year's observations. And you can do that for every year. So year over year, you can contrast one year to the next. This was my year in review for 2020, just over a couple thousand observations. I observed 996 species in 2020, and I don't have all the stats here, but you can, on that page, you can go and drill down and get a lot of different context around what months of the year were more observations, or where there was more species diversity, and start drawing some conclusions around, well, in my case, like maybe there's one species that I only see for like 1 month a year, but I see it in that month every year. The first year I observe it, I don't know that, and I don't really even know to expect that. But if you observe for 5 years, then like if you love that species and you want to see it, it's coming up next month. Start looking for it, because it'll be here, and those are really amazing things to kind of discover on your own, rather than just reading it in a book or watching a documentary. And you would be surprised at how many really cool things in your own yard that you can observe and learn by just paying attention. And this is a kind of a tool that helps you pay attention over time. So that's my whole thing. Hopefully it wasn't boring. I appreciate you guys, hanging in there with me. I don't think that I saw all the questions, or if there were questions that I missed, please, you guys point them out to me, and I'm happy to talk about anything that I covered. But
yeah, Clayton, I think you got most of them.
All right.
Yeah, along the way. So I got a question for you. I think a lot of people loved all those pictures that you had. Did you take most or all of those pictures that you embedded in the presentation?
Yeah, I did. The slides that had the couple of slides where I was trying to show a little bit better about how to identify our local snakes and the snake pictures. I do have a lot of snake pictures that I took in my yard, but a lot of those snake pictures weren't. They were from the internet, because they were good diagnostic representations of what I was trying to share. But all the other slides, 99.9% of the pictures were from my yard, so that I took. So, and even the space pictures I showed, those were also from my yard.
And Maury wants to know what your fascination with tardigrades is.
Oh, I just think they're cool. They're called water bears. They're just these mysterious little creatures. They're I don't want to say they're like microscopic. They vary in size. They're very small. You probably need to look at them under a microscope to see them. But they're very, very hardy. They can endure extreme temperature ranges from freezing cold to so hot that we wouldn't be able to survive in. They can live without oxygen. They can live in outer space. They go into this state when it's dry or there's arduous conditions. They go into the states called cryptobiosis, where it's kind of almost like a stasis. If you ever watch science fiction movies and they put people in suspended animation and send them off in the stars, tardigrades go into this cryptobiosis and they can exist in that state where it's almost like they're dead, but they're not, for years. And then they get hydrated again and they kind of come out of cryptobiosis, and then they're alive and kicking. And I think they're, in their own way, they're kind of adorable. They're just a very mysterious, exotic form of life on the planet that is not like anything else. And I think we all, largely just take for granted that they even exist. But I find them pretty fascinating.
Probably we've been at it an hour and a half, so we probably ought to call it a day. But first, thanks to Clayton for sharing all this incredible stuff. I think if anybody, especially all the interns, don't think you can do things in your own backyard, just take a look at what Clayton accomplished here. It's fascinating. And if anything, it's a glimpse to what intern training really is. Intern training goes on over, a period of 3.5 months about. You're going to get a wide diversity of stuff like this that is going to come from all different directions. And like anything else, especially when you get into master naturalist training, everybody sort of finds their own place of interest. So maybe some people like birds, maybe some people like bugs. It's all over the page. Some people, I spend a lot of my time at the Lake Livingston Conservation Project. So there's a home for everybody. So with that, Clayton, thank you so much for spending some time. And for all the people that are interns, you can record this in VMS under intern training. And this would be 1.5 hours, and it will be additive to the training that you're going to get anyway once we can get training started up. So, Mari has one last, and Peter Jensen just chimed in. For those of you that are Heartwood members, this is 80 hours, yes. Unless Peter wants to be an intern again. I doubt he does. And Mari wants to know if you'd be willing to give a nature tour of your yard for Heartwood.
Yes, I'd be happy to do that. I don't know. Probably the best time of year to do it would be in the spring when things are blooming and life is flourishing. It's kind of.
I think Mari knows how to hunt you down, so that could be that would be a follow-up conversation, I bet.
Sure.
So.
Thanks everyone for having me on. I'm just like you, just a regular Heartwood member, and I have a passion for nature, and hopefully you'll find the bits that you love and chase after them as you go through the program. So thanks so much.
Yeah, and as part of the intern training, something that Clayton and I got exposed to, there were numerous times that our teacher, Terry MacArthur, brought in other Heartwood members who talked about how they spent their time volunteering. And it just shows you the diversity and options that you have to go out. And so we'll do the same thing for intern training and have lots of people drop by and say, hey, if you're interested in this, and you're going to meet a whole lot of new people in this community. It's a lot of fun. All right, folks, let's call it a day. Thank you again, Clayton, and thank you all for attending. And we'll keep you posted on intern training as soon as we hear some more.
Happy New Year, everyone.
Happy New Year, and have a good weekend, please.
Thanks.
Stay safe.
Bye-bye. Yay. All right. Thanks, Scott.
You're welcome, Mari.